Chapter 2, Section 1 is about algebraic basics. We'll talk really briefly here about expressions, equations, inequalities, and what these things called coefficients, variables, and constants. We're really here laying the groundwork. We're defining a few things. We're getting comfortable with a few things that will exist in algebra and in math for the rest of time, for all of the rest of math you do. So this stuff is fairly simple in complexity, but is so foundational. It's really important that we get a good understanding of it. So there are symbols within mathematical statements. Now, this is the way I titled this is a little bit confusing because I have the word expressions here. A mathematical expression is not a mathematical statement. A mathematical expression is simply a combination of mathematical terms and operations in a single set of, it's a finite amount of those things. So for example, 3x plus 2 is a mathematical expression. It's simply terms and operations combined. Okay, so we have multiplication between the 3 and the x, and then the addition between the 3x and the 2. On the other hand, an equation or inequality would include those things and one of these statements of equation or inequality. And so we have 3x plus 2, maybe that equals 6. Well, now see, this is a statement, is simply it's stating the relationship between two different mathematical expressions, because 6 is just a number, but it also can be considered a mathematical expression. So some more examples, maybe like 3 half, we'll just use 3 and 2 already. Let's do like 5/4 x plus 7 halves y, right? That is a mathematical expression. And then an inequality might be that 5/4 x is greater than 7 halves y. Like that would be an inequality, okay? And so these things, if you're not familiar with these are, this is a greater than sign. It means the thing over here is greater than the thing over here. And then this is greater than or equal to, so that means the thing on the left could be greater than the thing on the right, or they could be the same. And then these are less than and less than or equal to. This not equal to sign is really not used that often. We usually use that sign when we talk about restrictions, when we talk about a value that something cannot equal, because there are certain situations in math, and those situations are when we divide by 0, where we can't, a variable or a unknown term that we don't know that has a variable definition cannot be one specific thing or several specific things, or else we would be dividing by 0 or doing something we otherwise couldn't do. So an expression, when we talk about expressions, more often than not, like boom, there's an expression in front of us and there's an implied instruction. And that implied instruction, when we're given an expression, is to simplify. Now, simplifying is not always something we can do. We're sometimes just given a simplified expression. But in order to understand what simplifying means, we have to kind of be comfortable with this idea of an equivalent expression. And so an equivalent expression is one that would evaluate to the same value. Here's an example of like an equivalent expression, okay? So let's say 5x and 2x plus 3x. And let's say that x, so when you say evaluate an expression, that means plug a number in and then like solve it using the indicated operations. So let's say x equals 2, and we're going to evaluate both 5x and 2x plus 3 when x is equal to 2. So that's pretty straightforward. We just plug in 2 right there. We plug in 2 here. I don't know where that little line came from. But we would see that this one evaluates down to 10, 5 times 2. This is 4 plus 6, which is also 10. So because 5x and 2x plus 3x they evaluate down at the same value, they can be called equivalent expressions. And going from kind of a more complicated looking expression, this one has 2 terms, to a more simple looking expression, this one has just the one, is what the process of simplifying an expression is. And there's basically just one thing that we do usually to simplify an expression. And in order to know what that thing is, we have to first kind of get our head around what a term is. Very simply put, a term in an expression is each of the little terms. It's each of these things, right? These things are all terms. And each term consists of different things. So for example, this 3x, when we think about the 3x, it has two parts to it. It has a coefficient. Okay, a coefficient is the number that is multiplying the variable. The variable is the other part of this term in this expression. Okay, and the variables, so like x squared, x is the variable here, it can have an exponent. It can be raised to some power. So in this case, it's being raised to the second power. So a coefficient in this list would be like the 3, the 2, the 5, the 6, the 2. These are the numbers that are multiplying into the variables. So 3, 2, 5, 6, and 2. Those are the coefficients in these expressions that are shown up here. The variables that we see x and we see y, right? We see x there too, and x and x. So x and y are the variables. And then there's one other thing here, and this is these like numbers that are all by themselves, where they're not being multiplied by a variable. They look like coefficients, obviously, but they're not because there's no variable next to them. And those are what we call constants. So any expression could be made up of any number of terms, and those terms will be variables and coefficients, or just variables. Sometimes the implied, if you saw an expression like this, x plus 2, there is a coefficient for that x. It's just 1. We usually don't write. You usually never see 1x plus 2. You just see x plus 2. So an expression has any number of terms, and those terms can consist of coefficients and variables and just constants. And so once we know what the terms are, and they're always separated by some operation, right? So 3x is a term, 1 is a term separated by that operation, 2x squared is a term, 5xy is a term, 3 is a term. They are separated by operations, and those operations are always add or subtract, or addition or subtraction. So now, how do we use this knowledge to simplify? Well, another thing that you should probably immediately think of when you hear the word simplify, when you're talking about expression, is combining like terms. So we can do that really, that is so fundamental to algebra. And all it means is we're going to take terms that are the same. And how do you know a term is a like term? Well, a like term are those that have the same variables to the same degree or power, same thing, right? So this is x squared and this is x squared, which means 3x squared and negative 5x squared. Those are like terms. I can combine them. Literally 3x squared minus 5x squared is just negative 2x squared. Here we have xy and negative 10xy. So those are like terms because the x and the y variables here, they're all the same. Okay, they're all raised to the first power. The xy of the first power, xy of the first power. So I can combine xy and negative 10xy and get negative 9xy. And then 7x and 4x, those are 3x, 7 minus 4x. Okay, so I can combine like terms. The simplified expression then would be, I just bring that constant down there. I can bring that constant down. I can bring that constant down. So these two things, the things in this row and the things underneath them in this row, they are equivalent expressions. The only thing that we've done is we've combined like terms. Combining like terms is something you will always need to do, because we prefer very much to deal with the most simplified version of an expression, especially before we evaluate, than we would a non-simplified version of an equivalent expression. Okay, now the last thing here is statements of statements. Statements are just a relationship between two expressions. They can be two expressions given of one thing and another thing. There's only three possible things. They can be equal to each other. They can be greater. They can be equal to each other, One can be greater than the other one, or one can be less than the other one. There's no way you can combine those two things. Like it's called the law of trichotomy. Given two values, they can either be equal, one can be greater than the other one, or one can be less than the other one. And that's it. You can't have simultaneously two values that are both equal to and greater than each other, right? That doesn't make sense. So these are simply just relationships between expressions. So 3x plus 5 is less than 32. 6 minus 9 is equal to negative 3. That's true, right? 6 minus 9 is negative 3 equals negative 3. Happens to be true. Okay, x squared minus 3x equals negative 2. If we are given a statement of equality and we're not evaluating anything, if it gives us that this is equal to it, then we are assuming that it's equal. It is stated that there's equivalency there. If we then say, is this true for x equals 6, for example, well, then you would be like, okay, 6 squared minus 3 times 6 equals negative 2. So 36 minus 18 equals negative 2. No, it doesn't, right? So it's false in this situation. But before we were evaluating anything, we are saying that these two expressions are equal to each other. Okay, x squared minus 3x and negative 2 are equal to each other. That's really it. The main thing here is combining like terms to simplify expressions. Once we got that, we just add a little bit of extra stuff on top, which we'll talk about in 2.2. And honestly, that is, I hesitant to say it, but that is the vast majority. Like, it gets more complicated, but we just build on those same set of skills, and we can deal with almost anything in the entire field of algebra.